Hello, lovely people. Today is another exciting day because I will be measuring distortion of this Down4Sound EZY amplifier. So as always, like in most of my testing videos, I'm going to try to explain all the setup, what everything does, and why we do what we do. So most of the time you can find like amp dynos of these amplifiers that will tell you the absolute maximum power under a certain voltage. But what it doesn't tell you is the actual distortion levels. And this is exactly what I'm going to measure. So let me tell you about all of this, what I have in front of me. This is my lithium and load bank. So inside there's a lithium battery, sits at 13.26 volts, and on the top it's a heatsink with resistors mounted from the bottom. And basically this provides a load for the amplifier. So this is a 4 and 2 nominal load resistors. I can swap them with these plugs, so I can have 4 ohms or I can have 2 ohms. Now the problem with this is that I built this to test like simple normal 4-channel amplifiers that do like 100 watts per channel, and I cannot test a 10-channel amplifier. So what I'm going to be doing is I'm going to be testing only one channel at a time. I will check all of these 8 channels because they should be identical. I'll check if they perform identical. If yes, then I'm going to just measure one. So the amplifier is not going to be fully loaded because in order to do that, I need like 2 of these boxes. And unfortunately, I don't have them. But the tests are going to be still valid because when you load all channels of the amplifier, you're basically loading the power supply and you're checking how much the power supply can support. But when you play normal music on normal speakers, that doesn't happen because you don't play into static loads. So even measuring one channel at a time is going to give reliable results. Now, what I'm going to be measuring with, I have this thing, which is a Quantasylum 403 audio analyzer. So this is an analyzer on the level of audio precision, just like a budget version, and it does the same things. It just doesn't have a load bank, doesn't have a power supply, so it's just a separate thing. It goes into the laptop and I can measure everything with REW. So very quickly, I'm just going to demonstrate you one measurement and I'm going to do everything behind the camera and then we're going to analyze all of it. So for example, now I have the amplifier not playing anything. It's on idle, and on idle you can see a current draw of 3.5 amps. So for a 10-channel amplifier, 3.5 amps is class D, so it's fine because 10 channels is more like 3 amplifiers. Kinda. So 1 amp for each, it's perfectly fine. Now my voltage, as I mentioned, is 13.2 volts, which is like a normal, more normal average voltage that you have in a car with the lithium instead of 15, 16 or whatever. Now, if I'm gonna play a sine tone of 1 kilohertz at 4.47 volts, so 4.7 volts into 4 ohm load is gonna give me 5 watts of output power. If I'm gonna play that, you can see this is what we see on the speaker terminals that are going out into there. So 4.48, something similar. And here we have a measurement. If you're gonna reset, this is the spectrum of distortion at 5 watts. So we have 0.02 THD plus noise, and THD itself is similar, 0.02. And we have all of these harmonics. So this is just a typical measurement at 1 kilohertz. I'm going to go through all the set of measurements that I'm doing because I'm doing sweeps, THD versus power, THD versus frequency, multi-tone distortion, and all that kind of stuff. If you don't know how to read these graphs and what they mean, I did make a video, I'm going to link it in the video description, how to read distortion graphs. And then after you watch that video, when you kind of know what you look for, then we can jump into the measurements and I'm going to show you how this amplifier performs. It's going to be very interesting to see because a lot of people say that like Down4Sound is same like all the other SPL brands that don't care about quality of the sound and it's all about power and all the amplifiers are super dirty and everything. But even from this I can see 0.02 it's not bad. It's not bad at all. It is 5 watts, so it's like on normal listening levels for tweeters and mid-ranges. And we're going to see how it's going to be when you push it. So we'll take measurements on 4 ohms and 2 ohms. However, I'm not sure if I will be able to measure the subwoofer channel in the back, because that subwoofer channel, I might measure just one because it's 600 watts and my resistors is 100 watts. So if I'm gonna unleash it full tilt, I'm just gonna burn all my resistors. So I might potentially do something with these, like bridge them in series and parallel in order to have a bit more power handling on these resistors. So we will see how it's gonna go. But for now, it's gonna take me a few hours to do all the measurements. Wish me luck, and we will see how it measures. So I'm measuring this amplifier. I just wanna share with you one thing that I found out. So all of these channels here, 1 through 8, if you keep the gains all the way down, it says the input sensitivity is 0 to 6 volts. What I need is up to minus 3 dB. If I feed this, which is 6.6 volts, 6.7 volts on the RCA's in, then I'm getting up to 1% clipping, spot on all of the channels. It's a plus minus half a dBFS or something like that. So if you're gonna feed it up to 6 volts, you're not gonna reach clipping, and you will need to increase the sensitivity a little bit. However, on channel 9 and 10, which are supposed to be the subwoofer channels from the other side, if you have the gain all the way down, you get the same output as through all the other channels, which is like 150 watts. In order to get more output up to like 600 or whatever is in the manual, you have to turn the gain up, just like that, something like that, like a quarter of the way up. Even if you're giving 6 volts input, you still need to turn the gain up. So this is a bit weird, and I'm thinking, is the sensitivity on this channel, it should be not up to 6 volts, but it should be higher, because with this one, this can output 8 volts, and I didn't manage to clip the input of the amplifier. So I would imagine this channel has much lower sensitivity, which would be like maybe 10, 11, or 12 volts. Similar to like Zapco amps that need very, very high voltage on RCAs. So I think this is something similar. This is just one thing that I want to share because I never encountered something like this. Oh, and another thing about the fans at the bottom, they're always on. Even now, yeah, they're working. So the fans are always on. Now, after I did all this testing, this amplifier is barely warm. Barely, but I was pushing just one channel at a time. So when I'm gonna be putting this in my car, I'll see how it behaves. I'm gonna put a temperature sensor on it, and if it's gonna be cold, I'm just gonna disconnect the fans because it's not that audible, but I would prefer not to have any sound coming from the amplifier at all, just because I'm not gonna push this amplifier to its limits at all. And a few more things because I will forget to say when I'm gonna do all of this. The efficiency is very high, about 90-95%, super efficient, class D. Shut up. And the channel separation is about 60 decibels, which is good. It's nothing amazing, but it's not bad at all. It's very, very good. So 60 dB channel separation. And one more thing. Okay, last one, I promise. So this meter that I have, it's connected directly to the battery, yeah? So it shows the current that is drawing and the voltage. And this is the voltage that's coming from the amplifier itself. So you can adjust the voltage with the little screw. So I managed to do like, you see 13.2, 13.2. However, see what happens? I'm going to play a tone which is going to be like probably like 200-300 watts on the subwoofer channel. So I'm just click it in. And look what happens. 12.9, fine. This one is showing 12.4. I'm going to disconnect it. It drops back and it shows normal voltage as well. I'm going to put it back again. So when the voltage drops, because the battery voltage, you can see, it draws 32 amps and the battery voltage is 12.9. And this one is showing 12.4. So if anybody knows why that is, please comment below because I'm not sure. Probably this meter is checking the voltage somewhere behind the caps, maybe somewhere on the output side, because on the input side The voltage is stable, it doesn't drop that much, but inside the amplifier, the voltage drops much more. So yeah, just one more thing to bear in mind. So first of all, we're going to have a look at how all the channels kind of work together, how they compare to each other. And for this, I think the best example is going to be THD versus level. So on the x-axis, you have the power, which is like 110 watts. And on the y-axis is the THD, total harmonic distortion plus noise. And we can see there is a little bit of discrepancy between these channels because it is 8 channels after all, and the last 2 is for subwoofer, so it's not included because it's slightly different. And from here we can see that the lowest distortion we have 0.01, and the highest somewhere here is like 0.03. A little bit peaks here and there, but we can say that this amplifier has a THD between 0.01 and 0.03, so on average 0.02. Now the main question probably is, how does this compare to all the other amplifiers, and is it good or is it not good? Objectively looking at these measurements, only from these measurements I can say that this amplifier is good. It's nothing really special, but it's not bad. It's good. It's really good actually, because in my kind of personal evaluation I always say that everything that is above 0.1% is bad, and everything that is below 0.01 is super good. So like I have some Alpine amplifiers that go down to 0.005 or even lower than that, like in this area. So this being 0.01 and a bit higher, it's really good. Now I did measure some other Class D amplifiers like from Hertz. I seen some other measurements as well, and mid-grade Class D amplifiers do measure very similar in a similar way. And these measurements, if we're comparing to like other big brands, this is cleaner than most Zapcos, because Zapcos, I see measurements of them, most of them is like 0.3, 0.5, some of them are even 0.1. So yeah, it is a very clean amplifier. Now let's have a look how the different channels are compared to each other. For this, we're going to have a look at a 1 kilohertz sine tone, and we're going to have a look at the noise and the total harmonic distortion. So for example, this, I put them in a row from the cleanest channels to the dirtiest channels, and they're not in a row. It's like not 1, 2, 3, 4, 5, but you can see 3 and 8 are the cleanest ones, and the dirtiest is 4 and 6. Now, why? This could be due to the actual channel locations in regards to the power supply, to all the other components like the length of the traces and that kind of stuff, because it's not a symmetrical amplifier. Even if you look like from the top, it looks kind of symmetrical from the first glance, but the channels are like not spread out symmetrically on the board. That's why you have these discrepancies. So it could be potentially that channel 3 and 8 are the furthest from the power supply. Maybe, I'm just guessing. But you can see from this, so this is a 1 kilohertz sine tone. The distortion for channel 3 and 8 is 0.011 THD plus noise. THD itself is 0.005. This is very good. Now the signal to noise ratio is 80 decibels on these two channels, 79.7, so we can say that 80 decibels. This is very good. Nothing like surprisingly exceptional. Like my best Alpine amplifier that I have, signal to noise is about 85, 86. So it is cleaner, but it's nice. All the harmonics, we do have quite a lot of harmonics. The third harmonic is the dominant one on both of these channels and in most of other ones as well. However, those harmonics are like minus 95 decibels down. So it is really low. Even on 8.1, this has higher harmonics, minus 90. It's really good. All of this is going to indicate that there's a lot of noise and the very top end, which is... sometimes it is a problem for Class D, but we cannot say that it's definitely like just because it's Class D. This is just to do with the actual amplifier design. But this is very good. Now, one thing that is not as good is the noise. So you can see the noise. Here it says minus 105. And here on the graph, we can see it's minus 116. Now, This noise is, from all the measurements that I've been taking, is Class D noise. Class D amplifiers tend to have a slightly higher noise, and that's why the signal to noise ratio is a bit lower as well. The Alpine V12s that I have, the ABs, they do have much lower noise, like minus 130, some even lower than that. So yeah, the noise is high-ish, but that does not mean that you're gonna hear any hiss through the tweezers or anything. Nothing like that. This is just relative to the best amplifier that I've measured. And you can see all those measurements in Distortion Factory if you're just gonna join there. So this is very nice. Now, if we're gonna have a look at the worst channels, which is 6 and 4. So both of them are very similar. And the main contributor to this THD plus noise, which is 0.03, was like 3 times as much as the best channels, is we do have harmonics, which are higher, but mainly we have noise in the higher frequencies above 10K. You can see here, there's the overall level increases and the amount of harmonics increases as well. Now, all of them are 80 dB and lower. On channel 4 is even lower than that. So again, it's not an issue at all. It's not going to be audible. It's just relatively comparing the best channels with the worst is 3 times the difference. Even if you have like 0.03, it's not bad. I've seen Zapcos that has harmonics like all the way up to minus 60 dB and measure kind of the same, just because those amplifiers have very low noise, which is like minus 120, minus 130, but much higher harmonics. So this is very nice to see as well. Now, you can see I took loads of measurements, like 54, because I tested every single channel exactly the same way. But now we're going to have a look at channel 8, which is one of the cleanest channels. So this is going to be like a representation of what this amplifier is capable of, because due to manufacturing discrepancies, some channels are going to be better, some worse, some amplifiers are going to be better, some worse. But I just took the best case scenario just to have a look what this amplifier is kind of capable of. So first of all, THD versus level, as I mentioned. In some channels, we do have a little bump here and there, but in general, it is a nice curve, because I've seen on some amplifiers, you have a massive mountain of distortion somewhere. So this amplifier, if I can summarize, is obviously everything is dominated by noise. You can see the noise is at the very top. The THD itself is quite low. You can see it goes here at the lower wattage is 0.01, which is very low and very nice to see. It is a third harmonic dominated, because the second one is all the way down there and the third one is dominated. Now you might say it might sound a bit harsh because it's a third harmonic. However, that harmonic is so low that I highly doubt it is going to have any kind of character. To me, from this distortion, it looks like a very neutral amplifier. Now, power-wise, it is cleanest for like up to 15 watts, which is for the tweeters and the mid-ranges. For the mid-bass, where you need like 50, 60, 80 watts, a little bit more distortion, but again, it's 0.05. It's nothing. That distortion is not audible at all. Now, power-wise, I did get about 140 watts up to 1% distortion. Now, this doesn't correspond with the specs on the datasheet just because I am testing at 13 volts. So 13.2, and when you load the channel like 150 watts, it drops down to 13 or 12.8. That's why the wattage is lower. If you would have steady 14.4 volts, you're gonna have probably 160 watts. So that is a lot of power. And all channels, almost all channels measure kind of identical. I have very similar wattage out of all of them. So this one single channel is going to handle even a very power hungry mid-bass driver, like 100, 120 watts for a mid-bass driver is going to handle with no issues, no problem at all. Now let's have a look at the THD versus frequency. And we can see that everything is very low. And again, everything is noise dominated. If you would lower that noise, the THD plus noise would go down as well. The THD itself on the lower frequencies, you can see it's super low. It's a very clean amplifier for a mid-ranges. For the mid bass, it's extremely clean. Now, problems, I don't want to say problems, but relatively speaking, it has problems at the higher frequencies in the tweeter range, where the distortion has kind of rising profile, and you can see the third harmonic kind of pops up, and at 6K we have 0.01. We're just objectively looking at these measurements. I'm not going to argue the audibility of it. Some beta amplifiers are going to have very flat THD versus frequency, where this rise is very minimal, just like somewhere here. So it does have that rise, it is a third harmonic, but in my opinion, it's not an issue at all. Again, we need to remember that is not a proper SQ amplifier, and this is to be expected. To be honest, I was expecting much worse performance that I get, and on other channels as well, the main thing that is rising is the noise, which brings the total THD plus noise a bit higher, but this rise doesn't go above 0.1%, which is very good to see. Now, we went through this already, so just kind of repeat, 0.013, very good numbers. Everything below 96, slightly more noise at the top end, but it is a relatively clean amplifier. Now the other measurement is intermodulation distortion, where we have two tones playing, 60 Hz tone and a 7 kHz tone, and we're looking for intermodulation, and we don't see any. So this is extremely nice to see that on the best measuring channels there's literally nothing. Yes, we do have the noise, as I mentioned, quite a bit higher. We have a rising noise at the higher frequencies, but this intermodulation is super nice to see, especially on the lower frequencies. There's literally nothing. Now, however, if we're going to have a look at the higher frequency intermodulation, this is the tone of 18 and 20 kilohertz. And here we see all those, I want to say, problems that I mentioned. So the harmonics, you can see the highest one here is minus 50, minus 53 dB. It is quite high. Now people say that you kind of might be able to hear harmonics that are 60 dB or higher. So you can see 60 is here. So all of these, in theory, they might be slightly coloring the sound, but again, at such higher frequencies, I highly doubt it that is going to be audible at all. But there's a lot of harmonics. And the best amplifiers that I have, we see all of these harmonics at like minus 80 decibels, which are here, and basically all of this is clean for the best amplifiers that I have. So it's not a tragedy, it's not a big massive issue, but if we're comparing to all the other amplifiers, it has some issues at the top end. Multi-tone measurement, which looks very nice. There's no issues at the bottom end, and as I mentioned, there's quite a lot of noise at the top end. And again, it's not a big massive issue, but yeah, there is noise there. And we have 14.3 bits of dynamic range. Now with 2 ohm measurements, we have extremely similar situation. I'm not going to go through all of them. The only thing I want to show you is the THD versus power versus level. So on 2 ohms, we have very similar situation with the THD. However, we have much more power. So up to 1%, which is here, we have 245 watts. Now, again, it is less than advertised just because I'm measuring at 13 volts. So lower voltage, lower power, just because the power supply is unregulated as in all amplifiers. But the THD is very nice. We can see it dips down to 0.01. And we can say it's super clean up to 180. So if you're using like multiple speakers that wire down to 2 ohms, it is very clean. And the last one I want to show you is the channels 9 and 10. So for this, we're going to take the channel 10 because they measure very similarly. And for this, the THD versus level, I didn't measure only at 2 ohms. I didn't measure at 4 ohms because if you think about it, I doubt that people will be using the sub channels at 4 ohms. They will be wiring it down all the way down to 2 or down to 1 ohm. So it's more useful to look at the lower impedance measurements. So for this we have up to 1%, 658 watts. And again, I'm not sure how much is advertised, but it's going to be lower just because I'm measuring at 13 volts. But the cleanliness, oh yes, it's very clean. It's kind of the same cleanliness as with all the other channels, which is surprising because these channels are kind of dedicated for a subwoofer, but they are full range channels. So up to like 470 watts, it's mega clean, below 0.1%. Now, for reference, my Taram Smart 3 base that I have, it is hovering about 0.1, 0.2, somewhere there. So these two last channels, especially if you like bridge it and you're gonna wire it down to 2 or 1 ohm, it is much cleaner than my Taram Smart 3. So it's going to be cleanliness, it's going to be an upgrade. However, that is not going to be noticeable at all because for sub frequencies below like 50, below 60 hertz, that distortion can be above 1% and you're not going to hear it. But it's just very, very nice to see that is such a clean amplifier with so much power. Now, THD versus frequency, this one is a little bit flatter. However, this measurement is taken at 100 watts of power. So we can see that 100 watts, where you saw on this one, I probably didn't mention that this measurement was for the channel 8, was at 5 watts of power. All of these measurements are for 5 watts, and we can see that the distortion is way down there. And for the channels 9 and 10, the distortion is a bit higher, but everything distortion plus noise is still very, very low. Below 0.02 is super nice to see. Now, the spectrum for these sub channels, it is a 1 kilohertz because, as I mentioned, is a full range channel. So 0.02, very nice to see. So these two channels, they do have a lower noise, but higher harmonics. And again, this is at 100 watts of output, and that's why we have a signal to noise of 86. It is much higher just because you have much more signal compared. So these two channels, as I mentioned, have higher signal to noise ratio and kind of similar distortion to all the other 8. Everything is below like 80 decibels, which is very nice to see. Since we're going to use this on subwoofers, I took a 50 hertz measurement as well. So this is 50 hertz at 100 watts, and we do have harmonics, all of those harmonics 80 decibels and down. There's a lot of them. It's kind of a forest, but it's still good to see that for subwoofers we have 0.02, which is super, super clean for subwoofers. Intermodulation for these two channels is much, much worse compared to the first 8, but that's kind of expected because, again, you're going to be running subwoofers on them, but it's still minus 80 and down, so it's very, very nice to see. For high frequencies, yes, it is a bit of a disaster, but if, I don't know, you're not going to play tweeters on a channels that can output 600 watts, so it is a useless measurement for this specific application, but I just made it because why not? Now, one interesting thing is that on 4 ohms, this channel 9 and 10, they're performing much worse. Not much, but like you can see 0.03 with the intermodulation as well. We can see much, much more noise. At the higher frequencies as well, much, much more noise. So to me, it looks like the channels 9 and 10, they prefer to be loaded down instead of running at the higher impedance. This is kind of opposite of all the other amplifiers that I mentioned, and especially with these as well, channel 1 through 8, the best measurements you're going to have with a 4 ohm load. The lower you load it, the worse the measurement gets. But on this channel 9 and 10 is the opposite. So if you load it on 2 ohms, it's going to perform better than loaded in 4 ohms. It's just a peculiarity that I noticed. And the final thing that I want to show you is the frequency response. So don't look at this bottom end. It is flat all the way down. It's just because of the measurement. And these are measurements for the channels 1 through 8 and channel 9, 10. So they do measure almost identical. You can see that between channel 8, which is the smaller power, and the channel 10, which is the big power, there's a very, very little difference. But the main difference is because of the load. So if you load the channel down to 2 ohms, you have this frequency response, which kind of tapers off. So at 20 kilohertz, we are down by 2.2 dB, which it's not a disaster, but it's not something very nice that we want to see. And for 4 ohms, if we're going to load it at 4 ohms, we have a bump of 1.4 dB at 20 kilohertz. What does this tell us? It tells us that this amplifier is load dependent. So depending on the load, you're going to have the frequency response. So if you load the channels all the way down, if you're using like multiple tweeters, multiple bullet tweeters, and you load it down to 2 ohm, you're going to have this rolling off frequency response. And granted, we hear up to 16K, something like that. So up to 16K, we're down by 1.5 dB. So again, it's not a disaster, but it's just something to note. And if you're going to use like one tweeter that is 4 ohm, you're going to have a little bump in the very top end. Now these measurements were taken at 96K, so we should have a frequency response up to 50 kilohertz. However, it does taper down, probably because of the noise at the higher frequencies. If we're going to have a look at this one where I showed you, like here, we have all of this. So probably there's like a switching noise for the power supply and that kind of stuff. So in order for that noise not to come into like audible range, the filtering network is quite low in frequency, and that's why it basically chops off everything like that. In the best amplifiers that I have, they do measure up to 100 kilohertz, up to 50 kilohertz, totally flat. But again, it's not a high res super SQ amplifier, so bear that in mind. And if most people are going to use it with an EZY DSP that has a Bluetooth, the Bluetooth is only up till 18 kilohertz. So again, it's not a big massive issue, but it's just something to note. Okay, so let's summarize this amplifier. Is this an SPL disappointment or is it an SQ gem? Neither. It is a very good amplifier with very good measurements. So objectively looking at the measurements and based on all the measurements that I've seen and that I've personally done, this performs better than an average amplifier. Yes, we saw some stuff happening in higher frequencies, but it's not a deal breaker at all. So I am very confident in using this amplifier, and it's going to be very interesting if I'm going to hear any differences between this and the Alpine V12s that I currently have. I really doubt it, but this amplifier as a whole in this form factor for the price that it sells, I think it's an extremely good amplifier. So it is highly recommended. And again, I do have an affiliate link in the video description. At the checkout, you can use code ROCKET88. I would be very grateful for that. And yeah, now I'm gonna put it in my car and I'm gonna use it. I'm just waiting for the DSP to come because DSP should come very soon. And if you didn't understand any of the measurements that I showed you, I'm gonna leave a link in the video description with a dedicated video which explains how to read all the distortion data, and you can visit Distortion Factory and see all those measurements for yourselves and just have a chat about this amplifier. So that's it. Thank you very much for watching, and I will see you in the next one.